Hello guys, welcome back to the channel. Let's continue the series on arrays. Till now we have seen a lot of basic questions. From now let's see medium level questions. In this particular video, let's see how can we solve two sum problem. From this video, we will gonna solve each and every problem individually. What is the problem? It's a two sum problem. Again, two sum is not something that you're thinking about, but it's something different. Two sum. What is this question? So basically we have an array, we have a target. We need to sum up any two elements to form the target. In this case, 5 plus 2 is equal to 7. Any other combination? No. If there are multiple combinations, we can return any of the solution. That doesn't matter, right? Now, let's see how can we solve this. Till now, we have solved a lot of basic questions. In all basic questions, we directly jumped into the solution. But now, let's see how can we solve, in how many ways we can solve this question. Generally, two sum problem can be solved in many ways. We'll start with brute force approach. For example, if my iterator starts from here, let's say I, we need to check 5 plus something whether it is giving the target or not. Okay, let's take j as second iterator, I mean nested iterator. Let's check 5 plus 6, 11, not possible. 5 plus 3, now j moves here. 5 plus 3, 8, not possible. Now j moves here. 5 plus 8, 13, not possible. Now j moves here. 5 plus 2, 7, right? For example, in this particular case, if I remove 5 and 8 and I'll swap 8 and 5. In this particular condition, to get the target, we need to iterate all the elements and at last we'll get 5 plus 2 equal to 7. It is around taking order of n square. What is order of n square? Let me write code for it. For int I equal to 0, I less than n, I plus plus. Okay. This loop indicates the outer loop, which means I starting from 8, it will go to 6, it will go to 3, it will go to 5, it will go to 2, right? We have an internal loop for j equal to I plus 1, j less than n, j plus plus, right? Why I plus 1? For example, if my I starts from here, right? If j starts from 8, already the combination is being checked. When I is on 8 and j is on 5, it's waste of time. That is the reason we are taking j is equal to I plus 1, so that every time it's checked for a new combination. If array of I plus array of j is equal to target, then we can return array of I, array of j. That's it. But will this solution be accepted by the interviewer? I'll say no, because it is involving order of n square. We are looping through the array and we are looping through the array every time by the I. If for example we have millions of elements in an array, it will take million into million, million square, right? How can we avoid that? How can you optimize the solution? Let's see the optimization technique. Well, this is taking order of n square. Now our goal is to reduce it something lesser than order of n square, which might be order of n log n, sorry, order of n log n or order of n, something like that. Okay, let's try. What I'll do, I'll simply sort this array. The resultant array would be 2, 3, 5, 6 and 8. Okay, and I'll assign two pointers to the array, one at the start, one at the end. I is equal to 2, j equal to 8. We will do addition operation. 2 plus 8 equal to 10. 10 is something which is larger than the target. If it is larger than the target, we'll move j towards left. If it is smaller than the target, we'll move I towards right. Okay, this is clear, right? Now, 10 is greater than 7, so we are moving j to left. 2 plus 6 is equal to 8, but still the value is greater than target itself. Again, we are moving j to left. You can see 2 plus 5 is equal to 7. Target matched. Great. We can return array of I and array of j directly. Very easy solution, right? What is the time complexity for it? The time complexity for this solution is order of n log n. Why n log n? You guys might be thinking why it is order of n log n. We are just using two pointer approach. But you forgot we have sorted the array. For sorting, it requires order of n log n. And for two pointer approach, it is order of n. In total, I would say order of n log n. Is there a better solution for it? Let's try. Let me tweak the question. Instead of returning array of elements, we are going to return indexes of it. Let's say 5 plus 2 is equal to 7. Instead of returning 5 and 2, we are going to return 0, 1, 2, 3, 3 and 4, the indexes of the respective elements. To solve this, to make it optimized, what we are going to do? Simple. We are going to take a hash map which consists of element and the index. Now let's take array of 0 is equal to 8. What is the formula here? The formula is pretty simple. We need to check target minus array of I, whether this value is present in the hash map or not. If it is present, then we can return the respective indexes. Let's check. Target is right now 7, array of I is equal to 8. 7 minus 8 minus 1. Minus 1 is there in the array or not? It's not there, right? Next step, array of 1, which is equal to 6. 7 minus 6, 1. Do we have 1 in the hash map? No. So simply add 6 with index of 1. Done. Array of 2, which is equal to 3. 7 minus 3, 4. Do we have 4 in the hash map? No. Insert 3 with index 2. Right. Array of 3. Array of 3 is equal to 5. 7 minus 5, 2. Do we have 2? No, we don't have. So add 5 with index 3. Great. Array of 4, which is equal to 2. 7 minus 2, 5. Do we have 5 in the hash map? Yes, we have. So we need to return the current index, that is 4. Along with that, the elements index that we found in the hash map, 3. We are going to return 3 and 4 at the end. Very simple, right? We'll start coding for all the approaches so that you can understand it much more clearly. The very first approach is brute force one. So let's code in brute force first. Int n equal to array dot length, and we need to loop through the arrays. For int I equal to 0, I less than n, I plus plus, and for int j equal to I plus 1, j less than n, j plus plus. If array of I plus array of j is equal to target, we can return new int array of I, array of j. Simple. If not found, then we can return new int minus 1 minus 1. That's it. We are done with the brute force approach. Now let's see two pointer approach, how it works, how to solve it. Int n equal to array dot length. The very first thing what we need to do, we need to sort the array. Arrays dot sort array. Arrays dot sort, and then we are gonna take two pointers, one at the start, one at the end. Int I equal to 0 and j equal to n minus 1. And while I is less than j, if array of I plus array of j is greater than target. What if the sum array of I plus array of j is greater than target? We can simply decrement the j minus minus. In best example, if the target is 7 and answer is 8 or answer is 11, what we did? We moved j to left. In the same way, else if array of I plus array of j is less than target. If it is greater than target, we are moving j to left. What if the sum is less than target? Simple. If the target is 7 and we got answer as 5, then we need to increment the j. We need to increment the j, I plus plus. If both the conditions fail, then obviously we found the target that, if it is not greater than, if it is not less than, then obviously it is equal to return new int array of I, array of j, right? At the end, if there are no such combinations, if I crosses the j, then we can say there are no combinations found. We can return new int -1 -1. We are done with the solution. So this is a code for two pointer approach using sorted. Now let's see how can we achieve the third approach using a hash map or hash set. That's up to you. If the interviewer says to return, if he says to return elements, we can directly use hash set. Now let's see. Int n equal to array dot length. For this solution, as in the previous approaches, we are returning the elements directly. So we'll stick to elements itself. We'll stick to elements. If it is elements, then we can use hash set. Hash set or simply set integer set equal to new hash set. For int I equal to 0, I less than n, I plus plus. What is the condition? Target minus area of I. If it is found in the set, we can return the current element and target minus area of I, which is found in the set. If set dot contains target minus array of I, we can return new int array of I and target minus array of I. That's it. If not, if not found, we need to insert the element. Set dot add array of I, right? At the end, return new int -1 -1. So this is the code, but there is a problem in the solution. We are using extra space complexity in this solution to achieve. Just cross check with the interviewer. If he's fine with the extra space, then stick with this approach. If not, just stick with this approach. Sometimes the array is given as sorted itself. If the array is given as sorted, you can directly implement the second approach. It will take you order of n without any external space complexity, right? That's all about the two-sum problem, how to solve two-sum in different approaches. If you have any doubts, please ping in the comment section. I'll try to clear out all your doubts. Thank you.